Hello everyone, welcome to Game Developer Guild's last tutorial for this semester, focusing on play. Here we'll be talking about, or just finishing off the coding stuff from last tutorial, as well as talking mostly about design and game design principles and how they apply to games. Okay, without further ado, so there's going to be 4 sections to this tutorial. The first is the overview. The second is the C# demo. Third is the design concepts. And fourthly, there will be design processes. Design concepts represent the abstract categories of concepts that you need to use in order to design your game more than just a stream of consciousness ideation that people usually tend to do when they start out game design for the first time. Design processes is a short primer on how to design design games in practice. We'll still remain a bit high level there. We won't get too deep into the tools, the practical applications. But yeah, as always, if you have any questions, just ask us in the social media pages. And the drive link is there for the C# demo. So today's 24th September. Do ignore the things after this because of lockdown measures. We've had to change some of that, so ignore the things in the weeks after this. We'll do another event, most likely. Game Dev Labs could only work physically, so that can't happen under lockdown. Also, the 8th annual journal meeting is postponed until a later time. We'll give a shout out when that happens, and we hope to see you there when we do. For membership fees, due to the COVID lockdown, Electric Boogaloo Part 2, we have to, we can't accept membership fees, and basically they're optional now. We really appreciate anyone who did donate to the club, those $5 for this semester. After all, our club is a voluntary club, so we spend our free time making these tutorials as well as organizing the club and stuff. There's a few things that, there's this collab that we want to talk about, which is the Game Developer Guild X Creative Arts and Industries collab. So the Creative Arts and Industries is a faculty in University of Auckland, and they focus on, first of all, that's the fine arts, then there's the music, but they're also interested in doing VR stuff. So under the extended reality label, which includes virtual reality and augmented reality, I'm hoping we could get a collab going with some of you guys. So if you're interested in playtesting or even developing, just DM one of us exec or email gamedeveloperguild@gmail.com. As always, if there's any other collabs that you guys want to do, feel free to propose to us during DM or in a DM or email at our club email. If you guys know any of the club's execs, that would be even better because then we could connect to them directly. Okay, on to the C# demo. So I assume everyone's downloaded the following files, which is, there's these slides. Part 2 of the coding behind the veil, and learning materials for .rar. As a reminder, the name of the game is the executable, just the executable. So if you want to see how the thing plays, then just look into downloading that as well, but that's optional. What you need is these two. Okay. So the Coding requires a coding editor. In my case, I'm using VS Code, but you could use Visual Studio if you prefer. And if you're from engineering, that's the default IDE because one of the courses there in part 1 asks you to download Visual Studio. I won't cover too much detail into how you've downloaded the IDE, but basically you go to this is for VS Code. You go to the main site, download for the version of Windows, and times 6432 build, and then install, and it's pretty fast. There's this bits and bytes slides if you haven't downloaded the IDE before. It's pretty simple, but just a reminder that whether you use Visual Studio 2017 or VS Code really depends on portability as well as how fast you want to load the IDE itself. If, for example, you only need to access code usually in one huge session and then jam there, then Visual Studio would probably be the better choice. If you need a small size and you want to be portable, i.e. you're working on your laptop and you expect to close and open your game development frequently, then VS Code will probably be the better choice for you. I won't cover the bits and bytes PowerPoint because I'm assuming here that all of you have at least one code editor to do your C# programming with. So I'll continue. Oh yeah, we also recommend downloading last tutorial slides so you could refer to some of the concepts that we assume you know from these slides onwards. So for this coding section, if you want to fully go through the game we set up, just follow these 5 steps. First, you play the game, and then you look and understand the code to see how it functions. We've isolated most of the super duper complex code, and you'll find that in a few of the folders underneath the script folder, specifically the playground and the white space folder. You'll find the code there is simple enough for beginners to learn how to code for the first time in Unity. If you wish to play around with the code, feel free to do that. Just edit some of the variables, and then you need to debug, of course. And then repeat, or take a break. So, if you want to import the game, this is what you do. This is slightly different from tutorial 2, so pay close attention. You want to open up Unity 2018.1.2 because that's the version we use for this game as well as for tutorials in the physical lab that we used to do club nights in. Create a new 2D project and then name whatever name it is, and then close Unity after it finishes building this game. In the File Explorer, using the files you downloaded in Learning Materials 4.rar, you want to replace all files except the new project .slen files, because that has the same name as the dummy project that you made over here. Should be full. Okay. Now you want to reopen Unity, and you'll realize that Unity has changed all the assets and recognized them for you. So you don't need to change anything, and you've already got the new game running already. I did take one file from the last tutorial slides, and that is the help please file. Basically, if there's any issue, if there's any error that you can't understand, there is always a forum post that explains what you want. The terminology may need to take some learning, but after you do, you'll be able to debug almost every problem online. Okay. So to make things easier, if you have one screen, open up Unity and then drag it to the right. If you have a big enough monitor, you'll be able to fit the code editor on one side and Unity on the other. That lets you see the code and edit the code while playtesting in Unity almost simultaneously. bonus points if you have 2 monitors, because then you can rotate the second monitor 90 degrees, and you'll be able to have a larger view of both Unity and the code editor. Now, the final steps before we get into the demo itself. First of all, play the game. You can access the new scene that we use for coding by activating all 5 switches in the switch state. Then you wait a while, and then a magical gate will appear, and then you shall enter this gate and be amazed. Here, listen to what the guide says, and then look into the keyx scripts found in the project window under scripts white space keyx. These are the beginner learning materials that I've mentioned earlier. Let's do that now. Okay, so I'm in Unity right now, version 2018.1.2. This is the main menu. So let's give it a shot. Let's activate all the switches, and now we wait. And it seems there's a guide here, and we have to press 1. Oh, I'm pressing the number keys on top of the keyboard. That triggers each of these clips. So what this guy just mentioned is to make his new script by right-clicking the project window and then pressing C#. However, without knowing how to code in Unity, that's kind of like making a recipe without knowing what the ingredients even are. So we're going to go to clip 4. First, we need to learn a concept called printing to console. Debug.log is what they usually use, but we use player debug.log so we could print to screen instead. Okay, so let's go directly to a scene so we could skip some of the fluff. And let's go to the script folder under white space. Okay, time to open up VS Code. Okay, so I have VS Code on the left side and Unity on the right side. That is how I prefer it, but if you want to change any other orientation, e.g. having Unity on the left side instead, then it's probably up to you. Before, the game tab and the scene tab was separately, so they were like this, which is kind of hard to see what's happening on screen. So I usually put the game in the same window space as the scene tab, therefore I could see both with a good enough depth of field. So on the left here, we see key for white space, blah blah blah. What is relevant, however, is this section over here. I won't go into each of these because I assume you've also done the repo.it folders file, as well as its questions. So just know that input.getKeyDown basically means that, if in the previous frame you press the H button, or whatever is the parameter in this function, then execute this code. In this case, it's the very simple string to print hello world. Okay. Now let's zoom in a bit here because everything's a bit zoomed out. Okay, so if you press H, it prints onto screen. You can see that the hello world in the bottom of the screen is changing in the screen instead of usually in the console. Now you can ignore these two messages, they're unimportant here. But hello world, it's called by playerdebug.log. Now I could show you the quick definition of this function. Basically what we did was we just made a log function so it sort of looks like the debug function, but it calls the debug.log like you would usually do and also prints it to the screen. But you don't need to worry about this file per se. Just know that playerdebug.log prints to both screen and console. And here you can see that the caller of this change, as well as whatever scripts led to that moment. Okay, let's look up the key 5. And here, there is a whole bunch of commented out stuff, and there's this one line here and this player debug.log line here. Pressing X. Okay. It says that there's no compilation errors, that's good. There's no errors other than, well, there's no errors at all, which is a good thing. You always want to have no errors in your code. And if you leave it for later, sometimes it compiles, sometimes it compounds, and then you just get a whole buggy mess of code which you never want to touch again. So it's good to always fix your errors before they pile up too high. I'll do a quick overview of the most common code errors, I think. And yeah, we'll move on to the next key after that. Okay, so first of all, if you realize if you just like simply uncomment the first line, it'll say the local variable or function named player game object is already defined in the scope. What this means is that you've declared another game object, which is exactly the same as another one you declared previously. So the compiler just says, what the hell is going on? Don't do that. And we don't do that. Either you change the name or comment the thing out. Another super common error is the player game object here is declared as a transform, but we're trying to like assign a game object to it, and that's not gonna fly. So the compiler just throws our type conversion error. In fact, you could see it if you look in the terminal here. Cannot implicitly convert type. You'll see this a lot. Everyone does. What it means is that you've probably put in the wrong like game object type, wrong type of variable in assignment. So make sure you change this back to game object. And of course. And now it compiles fine. In the first section, that is the section from here to here, these are all compile time errors, which means that the compiler tells you if you made a big mistake. And that's actually a good thing, because you know how to fix it, that means. Just by pressing the errors in the problems pop up. And you could open this up, this little window, by pressing on the bottom left here. Another common instance of a type conversion error, changing a singular object and assigning it into an array. Oh, not assigning into, assigning as an array. You can't magically conjure up an array out of just a single object. So this fails. And you know this is an array due to these square brackets. If, however, you did something like find game objects, that is the plural, then this is completely fine, because you're assigning an array into an array. That's okay. Another super duper common error is this. I wonder what's wrong with this. Type or namespace name game object cannot be found. Okay, well, you know a game object exists, but the reason why this caused an error is because it's used in the wrong context. In this case, you're trying to make you're trying to access a game object of this script, but then it's like you're trying to assign something into it, a declaration of an object of type game object, but that's wrong. So the compiler just like gets super confused and just tells you, oh, that's a big error there, so make sure you fix it. In this case, this is a typo. So typo is easily one of the most common errors in code. In fact, being good at code usually makes one a good speller too. Oh, there's the duplicate declaration. And yeah, that's good. Another common error is if you use a method that the compiler doesn't know what you're talking about, i.e. you're accessing the wrong type. You can't use a method that doesn't exist in a type and it comes up with type or namespace not found, or something like that. Speaking of typos, just simply forgetting the semicolon is a very common beginner mistake. Semicolons tell you which lines ends and which line begins. Well, which line ends anyways. So don't forget those. Also another typo is these three lines. As you can see, this one's missing a closing bracket. This one is missing a square bracket. And this one is missing one of those arrow brackets that you use whenever you're getting a component. Alright. These represent typos, usually. They could be caused by other things, but typos is if you're just starting out something to double check. Whenever you're writing a code and there seems to be tons of errors, they just pop up magically for no reason. This is an error because, as you'll see later on, you need to put an F after every decimal figure, or else Unity won't accept it. It simply refuses to take double, because it prefers floating instead. So simply putting an F solves this problem. And we'll get to two runtime errors. I believe these two are the most common, certainly the most common I've experienced. That is the no reference exception. Now these are runtime errors, which means they only appear whenever you go into play mode. And that's super annoying because you don't actually know it's the error until you go into play, and you've already wasted like 20 seconds or whatever loading the game. So in this case, I'm trying to find a missing item and then using said missing item. Now, there's no missing item, as you can see in the hierarchy. Like, nothing here. Oh, actually, better yet, just search for it. And you can see that there's no missing item at all. Oh, the search is in case sensitive, by the way. So if you were to play this again, okay, let's press the X button, which will activate this line, this bunch of code. You can see. Oh, hold up. Oh, well. Seems to be just fine. Okay, hold up. Let me just use an actual damaging method. Get component. Let's see, what's a common component? Transform. Usually expect most game objects to have transforms. So let's just assign this into a random transform TF, which we'll just use for testing purposes. So I repeat, finding a missing game object returns null if the object can't be found. So therefore this gets null. And then therefore I'm trying to use a null object, but that doesn't work because null doesn't have such a thing like transform. Okay, so let's skip everything. And you see, no reference exception. Blah 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 basically means that this line here, 69, does not have a component of type transform within this object. And as you can see from the line above, that object is assigned to null due to this method here. So the fact to fix for this is that to fix no reference exceptions is you need to go up the chain of code until you find the original missing piece, sort of like a detective game. Okay. And this other runtime error that's caused a lot of pain for many programmers everywhere, the array out of bounds. So when you're learning Unity or C# or any programming language that uses strictly defined arrays, you define how big the array is at the beginning. If you try to use something that's bigger than the limit, in this case 2 and 3 are both too large because arrays start at 0, so this will be input 1, input 2, error, error. Okay. So let's save and test this out. And what do you know? Index is out of range. Click on the error, leads me to the exact line that caused error. In this case, both of these errors. So even if I comment this one out, this will cause an error too. Yep. If I comment both out, this should work. Yep, no compilation errors there. If I comment out one of the normal ones, you may think, oh, there's 2 entries here, therefore this may work. But as you can see, array 3 doesn't even get initialized because it doesn't follow from 0. And is out of range again. How annoying. So make sure you never put these two colon array out of bounds. Okay, now that you've got the errors, I'll just briefly cover through the remaining 6, 7, 8, 9, and 0. With I'll leave that up to you to figure out which one's comment out or not. Okay, so this is 6. basically this covers the primitives. You would have learned this from the previous tutorial from report.it. There's just a lot of commenting and uncommenting. Test out each aspect of everything. Once you've done this, you should be able to make some very basic code that manipulates these types. The string type, which you've already seen in the hello world, then there's a boolean, true or false, int, whole numbers, and there's of course the floats. The real numbers with decimal points, which must be initiated with an if. Seven is the conditionals, very useful. Just a simple example here of an if statement. And there's random.range, which generates a random number. Alright, and key 8 here. This one goes through the loops. In this case, the for loop and the while loop. These two do exactly the same thing, it's just they're written a bit differently. So whereas this one uses while and increments the counter variable inside the loop, the for loop does everything in here. People tend to use for loops much more than while loops due to its compactness, but whichever works for you. I will say, however, infinite loops are not fun. I won't do it in this tutorial, but if you want to see for yourself, haha, well, you can learn it the hard way, I guess. Just make sure you save before you uncomment this out. In the game, let's press Y and U, see what happens. Oh look, it just spawns sashimi. Okay, I'm gonna need a cleaner to get rid of this mess. For key 9, that is the start and update loops, which is what they call Unity's magic functions. Basically, at the start of each scene load, start runs once, and then update runs every frame. So this is where you usually do like checks for stuff. For example, whether I press a button or not. In fact, let's look at an example of. Oh, by the way, these fishes comes from me pressing Y and U from the previous file. If I press O and P, O represents, well, O outputs 0 to the player debug log, as you can see from the game screen. Basically, that's how much counters increased while P is held down. So if I hold P for, say, 3 seconds, it says 89. That wasn't 3 seconds, that was more like 1.5. Let's see. The good thing about the console window is you can see the time that entries happen, so you could like roughly measure when things happen. In this case, I've held it for 36. Oh. Hold up. to, yeah, roughly 2-ish seconds. And that ran approximately 89 update loops in by the time I've held those buttons down. So that's probably like 30 frames per second. Of course, if you try to hold for as little as possible, you realize that you can't exactly get it to 1. Oh, the zeros come from me double pressing O. Yeah, it basically means that update loop runs really fast, and if you were to do something that changes every update loop, it basically feels like real motion. Essentially. For simple movement, this is perfectly fine and good for prototyping with. Now, key 0. This one basically just changes the scene. using scene management. After 10 seconds, I change the scene. Now, he's a bit hard to see underneath all these sashimi, so let me just... Oh, well. I can't get rid of these sashimi. Oh well. I'll just see what happens. And this is the second scene. I left it for you to figure out. But a key thing to note is getting things, you have to jump into this green window from where you are by editing the code and inspector itself. That should be a fun exercise. I'll leave that to you guys. Back to the design tutorial. So let's talk about design concepts. I'm just going to cover briefly the first two in detail, and then the rest, except for game design documentation. I'm going to do 1-2 of design concepts and 1-2 of design processes in detail. So first of all, these are 6 elements. Actually no, first of all we'll consider why we need to be thorough with this designing process. Consider this. Say you have a game idea, and then you have a group of friends who you want to share this game idea with. You could say something like, oh, I want to do I don't know, Minecraft clone with voxels and stuff. But then you realize you hit a terminology problem, which is you have to make up words as you go along to describe things, and that can get kind of confusing for both professionals and lay people alike. So the whole point of designing is also to help with communicating ideas across a common understood terminology. Another point for learning design is exploration of game ideas, as well as originality and trying things that other people haven't tried before. Also, given limitations, as in many game jams, design helps you consider what is or what isn't allowed or well-functioning ideas before you even put pen to paper. Thirdly, expression. As you know, some games have a very, very strong sense of style. There's some more words for that, for the style or theme, and these are very specific definitions. If you talk about your design and your own style of expression in a game, then you'll look a lot more professional if you know the commonly understood terminologies or processes that go behind game design. And it won't just be luck. Fourthly, there's project management. If you write down your designs in a well-written and well-maintained game design document, then it'll be much easier to change and share in future if you ever onboard any other game developers. Especially for open source, this is pretty important. There's many other reasons too, but if you keep these in mind, you'll find out and you'll plow through the more abstracty parts of design that may be boring for those visually minded or hands-on oriented when it comes to learning. Okay, so here, elements are the moving part of the game. So these these 6 elements of play are the moving parts of the game. So these are the very, very, very basic parts of each and every game. Every game has at least some of all of these. Even if you're playing for example, a walking simulator, you're still pressing, I mean that not in the pejorative sense, but in the descriptive sense. You still click on the next button. As for goals, even Minecraft has goals, even if you make it yourself. Rules, same thing. Objects, even text-based adventures have these abstract objects like, I don't know, a grok or a dragon to fight with. Play space, even in the thinking games, there's a play space which is your mind. Players, even in computer versus computer, there's still a player, and that's the person looking at the game. All of these 6 elements of play make up a game, and you can make limitless possibilities with these 6 elements. Now, action's the most obvious one. Let's give a general example. Let's say soccer. In actions, soccer would be kicking the goal and moving around, and goalkeeping. For goals, scoring a ball in the net, that's a goal, and the goal is ultimately to win more points than your opponent's team. Rules, well, there's an obvious rule in soccer. You can't use your hands unless you're the goalkeeper. You realize that rules can actually make games much more fun, and that's something to consider when you're designing games from now on. Limitations as well as conceptual or physical limitations could affect the game in a positive way. There's objects, for example the soccer ball itself. There's the play space, the football field, and of course there's the players. So this example here is of a top-down view of soccer. You can see the players, objects in the ball, the field itself, and the nets. Yeah, these are all pretty apparent. The 6 elements of play. But what about chess? Well, for chess, actions, repositioning a piece. I guess if there's like sacrificial chess, you could also revive a piece or pass it to another peer if you're doing pairwise sacrificial chess. For goals, defeat the king, of course. For rules, there's of course pawns can only move in a straight line, kings can only move in one square, etc, etc. Objects, the pieces themselves, play space, the board. Players, the 2 players. It's a fairly clear-cut example of each of these elements. Well, but for Fall Guys, this is a more modern game, and I'll leave that as a challenge for you to figure out. Something important to note, however, is that the actions is easily the most obvious and the thing that causes the most fun. Well, depends on the type of player. But actions is easily the one of the most funniest thing about this compared to most other battle royales. Unlike other battle royales where you shoot or have melee combat, this one's just moving and jumping. Actions and rules in this game makes this game different from other battle royales. And that's something to consider when making your own game. Do something interesting or different, or seeing how different elements interact in a unique way. On to the next design concept, which is the 10 tools of design. Now, unlike other tools which we've covered, like animation or art or programming or music, well, not music, sorry, Unity, software programs, they're physical, well, physical in the digital sense, I guess. Use them to produce the results that you want. But in tools of design, they're more abstract. So it's like a trade-off. These are the tools, and I mean tools in the abstract sense. Use this to balance the design of the game, and ultimately what makes the game good or bad through these 10 tools. Okay, so the first one is constraint. Limitations on player via designs of actions, objects, and play space. So if you've heard of Benefodi's Getting Over It, the limitation is you can't just walk around and climb the mountain. No, that would be too obvious and simple. So Benefodi decided to make a very annoying game where you use only your hammer to climb the game's mountain. It's a constraint, and it definitely makes people enjoy it, particularly if they're into masochistic games like these. And yes, that is a category of game called masochistic games. That's the first constraint. Other examples of constraints, like football, can't use your hands. Alright, onto the second tools. There's direct and indirect actions. So imagine pinball. You only pull the right kicker as well as the two flippers in the bottom middle. Those are the direct actions. However, there's many indirect actions that you also do when the ball bumps around the bumpers as well as the scoring gates and other objects in the field. Something to note here is the more indirect a game, the more there's a sense of exploration. There's of course the goals of game. As mentioned earlier, goals is what players aim towards, and of course they could be very useful for making a strong and authorial game. And by authorial, I mean that the developers give very little room for players to move around, as in like in an abstract way. In rugby, people can only move in the field of play, but shaping the goal to funnel people's experiences towards the goalposts is an example of using goals to design player experiences in a positive way. In fact, most field sports tend to have something like this, where there's a singular goal on opposite ends of a field. That's not an accident. The next tool, challenge, ways in which the game resists players, as well as difficulty of the goal or game concepts. So it's pretty self-explanatory. Challenge is how tough the game is in achieving said goals. Of course, there's the skill, as in like taps per second, for example, in a MOBA game or real-time strategy game. But there's also the conceptual difficulties, such as in Phoenix Wrights, understanding the links between the story and trying to poke holes into the opponent's testimonies. That's an example of a abstract or conceptual challenge. This tool of design is actually 4 mini tools bundled together: skill, strategy, chance, and uncertainty. These 4 tools are connected together, and you can't change one of these without affecting the game design significantly. In this example, poker, for example, there's of course a lot of chance in dealing with the cards, and there's uncertainty in your opponent's play. But you could also strategize and master the skills despite all the RNG. Hearthstone, for example, is another game with chance, yet there's still like pro players who take advantage of the strategies and player strategies that oppose them in this game of RNG. Wow, more RNG than the typical card game. Even if there's no chance, there still could be uncertainty. So other players could give uncertainty to the playing field, especially in like sports or other multiplayer games. You don't know whether the player is good or bad, or whether they're aggressive or defensive player. I'll give this pinball example again. Decision making and feedback. So in pinball, feedback is pretty obvious. You can see where the ball ends up, but imagine that for another game where for example, like a butterfly makes a giant change in a wind far away. That's chaos. If there's very little useful feedback for a player, they'll take different actions compared to pinball, where everything is easily visible and people can get feedback easily. Decision making, well, that means that how easy it is to make choices in the game, substantial choices. sort of like what you see in branching narratives in story games. These two are closely connected because without good feedback, then players might not bother with not bother with good decision making, and vice versa. If you get feedback without decisions, then like what's the point? Abstraction. This is a pretty complex to understand tool. Basically, by abstracting a concept in real life, you could give better intuition for the player. For example, in here I'll use chess again. It's actually a war game, but people usually don't think of it as abstract, because it's just pieces. Like, how could this be like a battlefield? No, battlefield is square. But you instinctively know from the pieces and the fact that the pieces are based off medieval wars, well, very loosely I should say, that you have to defeat the king in order to win against the opponent. That's an example of a very useful abstraction helping the player in making good play experiences or learning the rules easier. Then there's theme, which is the logical framework of how a game is represented. This game over here, this is called Inside, of a kid trying to escape. I admit I haven't played this game myself, but the theme itself is dark and gloomy, and that's intentional to give a space of possibility more focused on atmosphere and narrative. And by space of possibility, I mean movements in the game and actions that the player could do in the game. The theme in this game supports the story as well. The ninth tool, which is storytelling. There's many ways you could do storytelling, and this example here is an example of a traditional narrative structure called the hero's journey, and it's also one of my favorite games. Basically, the hero's journey is a well-defined narrative structure that the creators of this game took and followed almost exactly, and as a result, the game came out with a very good narrative focus when designing, and therefore in development and of course on release. It was praised for good storytelling. Of course, you don't have to follow the traditional ways. You could use more experimental narrative structures. Making new story structures is far more publicly encouraged these days than back in the olden days, where people would just reject any weird story as, oh, it's too weird, I'm not going to buy it. And for the last, context of play, this is the physical experience of the players themselves when they play said game. For sports, it'll be on the field. For computers, it's on the PC, and of course for phones, it's on the phone. So we all know the situation here of, oh, doesn't everyone have a phone? And the whole meme. But you can see here that the controls are designed for mobile games. So it's important to take into account the device, the location. For example, people don't play mobile games like as often at home as they are in travel or commute, because that's where most people who play mobile games would play their mobile game. If it's multiplayer, would they be playing together on a LAN network, or online, or physically together? So yeah, that's the 10th tool. Now onto the sections 3 and 4, which is kinds of play, and after this would be the 4 player types. Both these would be briefly touched upon. Compared to the previous ones, these are not so rigidly defined. For these the kinds of play. Thinking ways about designing games that produce different games. All good game designers probably would have played a lot of different kinds of play to experience and cross-inspire ideas for each other. for each and every kind of play. So there's these 8 examples I'll give you. This isn't an exclusive list. There is potentially more that come out in the future, depending on technology. But generally, there's these 8 categories of games of today. There's the competitive, sports, cooperative, journey, which is a multiplayer game where you work with each other towards a common destination. Other cooperative games include D&D, up to a point. Cooperative games include... Actually, I don't play much cooperative games now that I think about it. But team-based games, also cooperative. Then there's skill-based. Getting over it is the perfect example. You can only finish the game if you master the hammer mechanic. Games like League of Legends, the more you master the skill, the better you get, and that's the whole experience. Oh, there is some cooperative in it. It's a mix of these two, cooperative and skill-based. Experience-based, journey, which I mentioned again. There's also Inside, which is that gloomy game I mentioned earlier. Both of these focus on having the player experience intense emotion or a memorable moment, and that's the point of the game. There's games of chance and uncertainty, which revels in chance to provide fun. Many games with these, obviously have RNG as a main factor. There's the whimsical games like Co-op, which is another game from the creators of Getting Over It, where you play as a athlete and you have to control the individual leg muscles. That's an example of a whimsical game. Another whimsical game is Fall Guys, where people just pile on top of each other in a dog pile and try to reach the crown. There's role-playing games. Dungeons and Dragons is an obvious example, but also any game where you could have extensive customer creation and individually created narratives. Here and there's simulation. Untitled Goose Game, Microsoft's Flight Simulator, all these are simulation based. To be a good designer, it's far easier to be a good designer through experimenting all these, finding what's best of each, and then take novel combinations of them, and or developing new types of play for combinations of these. Something that's competitive and skill-based, or multiplayer online battle arena. Games of chance and uncertainty, mixed with, say, competitive, or battle royale is kind of like that. Whimsical and competitive, Fall Guys is definitely an example of that. It's not easy to categorize any game into any one of these kinds of play. These are more like traits, you could say. Now, onto the player types. So there's Bartol's 4 kinds of players. I mentioned this briefly in the launch night, but basically there's this guy Bartol, Richard Bartol, noticed how there's 4 types of people, and he likened them to suits of cards in a deck, and that they all have different self-goals if given the chance. This is a pretty old work. There's many more theories that are newer and much more comprehensive, but I like describing this because it's a good way to demonstrate why you should also cater to players who may not be your player type. And in return you'll get much more larger audience, or maybe even some new ideas and perspectives. So, I should mention that you don't have to fit exactly one. You could be a spectrum of like 0 to 100% of any of these, and 100% is pretty subjective too. So, the achievers here, that is the spades, The spades is the achievers, people who want to measure how much of a collection or something. We usually see these as collectionists or completionists, and they're interested in attaining a game or their own goals. They also include speedrunners and people who just like having a shiny badge. These people usually tend to like to challenge themselves and feel happy whenever they accomplish something they deem worthy. For the explorers, the achievers is a diamond, because a diamond signifies, well, it's better than gold. Explorers is the spades. Basically, they want to explore the full breadth of the game's space of possibilities, or in more casual terms, they basically see all the game has to offer, and they want to seek it out. Bugs, hidden areas, storylines. If anyone remembers from the original Pokemon, hiding underneath the truck is a Mew. That's an example of an explorer. So, explorers are content to simply understand the game more fully. They also want to know the full potential of the actions and objects within a game. So, if there's a narrative tree, then you expect the explorer to want to explore each and every one of them. In fact, I'd say I'm mostly an explorer too, because I tend to do that a lot, actually. Third is the socializers, represented by the hearts. These people don't focus so much on the game as they focus on the other players. So co-op campaigns, competition, basically if there's multiplayer, socializers are drawn into it. Sports games, a common place for socializers to meet up and chat and hang out. Dungeons and Dragons, yeah, basically where there's multiplayer and other players interacting, then you'll find socializers to prefer this type of game. That's not to say, however, that they don't like other games. For example, they could be a mix of explorers, achievers, or killers, and therefore have their own preferences when playing single player versus playing multiplayer. Last but not least is the killers. Now that's a pretty a violent term, I'll admit, represented by the clubs. Basically, they want to be the people who impose their will on other players. Usually they want to be the best in other people's eyes, and not only want to win, but dominate the game. So you see these as the battle royale people who go around destroying every other player, having like 10 player kill streaks. Those people playing Tetris 100, defeating like 30 people. These are the killers. That's not to say it's a bad thing, of course. It's just another player type. These people want to not just win, but completely make sure the other players are nowhere near their level of ability, so to speak. So these are the 4 types. If you could categorize into yourself into one of them, that might give you insight to what type of games you might like playing. Of course, that's the player perspective. From the game design perspective, what you would do is you consider each of these and think, oh, if my game doesn't appeal to these, should I either A, broaden the appeal so it includes them, or B, focus exclusively on the player types that I've already appealed to. That's a game design choice. Now, as I mentioned earlier, the more authorial the game, the less the player can exhibit these traits. For example, Minecraft. It's extremely open. People could do whatever they want. Killers would be able to play like battle royale games on Minecraft. Explorers, they could just explore the procedurally generated lands. They could also, if they're an achiever, build a, for example, very majestic building, or even a computer out of redstone in Minecraft. Socializers, well, it's apparent, is multiplayer Minecraft, and it's also a very frequent social hub for younger players in today. Now contrast that with Doki Doki Literature Club, which is a visual novel. Most visual novels don't give the player much choice on what to do, and therefore all 4 player types are kind of like guided on what the game developer wants to express. That's what I mean by being authorial. The more authorial, the less openness of the player to perform different actions. So Minecraft would be extremely unauthorial, whereas visual novels would be very authorial. Now, let's compare Mario Kart, for example, to the 4 player types. As expected, killers, socializers would have a blast playing this game. And achievers, well, it depends on whether they view Mario Kart as something worth achieving. If they're a kid, probably yeah. But someone who's really good at racing games, they'll be like, nah, that's not worth it. And explorers, well, I don't know, could you explore Mario Kart? Perhaps. But they'll probably be out testing bugs or trying to fly out to the furthest ends of the racetrack. But explorers don't generally have fun with these type of, or Mario Kart at least. Oh, that's not my experience. Anyways, these are the 4 player types. It's not just to know the types, it's also to consider potential players' experiences and cater the game towards them. Or there's many other player type theories out there for you to follow and cater towards too. 4 player types is actually pretty, well, I'd say it's actually slightly oversimplified compared to the modern personality types of today. Now, design process. Thoughts to action. So I'll briefly cover over the iteration and the game design document. So the main gist of this, I won't go into too much detail, because if you've just started design, then even this, going into this cycle would be a huge step. So these 4 steps: conceptualize. In this case, it's represented by these 2 circles. So you have an idea, you brainstorm ideas for it, or you want to test it out. You think of a way to implement key mechanics for the play experience. And I should mention, develop an idea for the game and game experience is equivalent to developing ideas for the play experience that you want players to experience. If you think of things in terms of genres, you'll only be repeating the genres of old and you won't be able to make new ones. So therefore, it's important to design for play rather than for genres or stuff like that. The second step is to prototype. So you need to, of course, play the game to test it. But just thinking over the idea in your head might not give the best way forward for the game. So you have to make sure other people play it to give their thoughts and experiences as well as perspective. So choose an aspect you want to test, then make a prototype. Then have people, yourselves, your family or friends, or even people you meet in a game show, or in a game dev meetup or forum, have them prototype, play your prototype. You evaluate, in this case it's iterate in this circle. You review the results for better understanding and improvement of game design. Now as you see, it's actually a circle here. In this cycle, evaluate includes like conceptualize and evaluate. But these 4 can be seen as a circle, or you can see it this way. Both ways work. The key thing is that it's a circle and that you continuously improve the game. Back in the olden days, people used to make games and just like, oh, wow, it's already been released, what's the point of going back to it? It's just a waste of time, and we can't get people's games back from them anyways. Well, that's old thinking. Modern thinking incorporates iteration for continuous improvement. So, hence the cyclic nature of design. For a game design document, most important, of course, is the game design document, the GDD. It covers everything and usually covers, first of all, a placeholder title, target audience, the type of play that the designer wants players to experience, as well as art or music style or particular mechanics that are considered key for the game. I'll show a game design document example shortly, but I'll cover the others first. Story, boards and schematics, visual depiction for easier understanding of game design. This one here, very exemplary, well, very detailed design of Pong. You can see it went through multiple variations from different colors and ended up this. Storyboards and schematics, their visual nature makes things easy to understand and connect different aspects of the game design document together. Especially useful for user interfaces and stuff like that. The third tool in the designing of, well, the third design document in double apostrophes is project management tools. For example, Trello is a very common tool that game developers use to note down what they want to achieve, what they're working on, and what they have achieved. Trello is actually pretty simple. There's actually a huge range of project management tools. Due to software complexity, people, if they wanted to do some crazy project management stuff, they'll also use the PM tools that, PM stands for project management, PM tools that software guys use and then appropriate it for game development. As far as I know, there's very few project management tools catered specifically to game developers. There's one called Hack and Plan, but use whatever you think feels best. If your game is simple, a simple Google document is fine. If your game is like a huge AAA game with like, I don't know, multi-years development, then probably best to stick to a well-known project management tool. Something probably even more complex than Trello. If you're an indie developer and you're already making games, it's good to try out at least the most basic, which is Trello, and then see if it improves your working ability and asset management. You leave a note for every asset you have or task to do, and you might find yourself being more productive in the end. Okay, let's have a quick example of a game design document. As you can see here, there's quite a lot of forms, but that doesn't mean that doesn't mean it's unnecessary paperwork. Actually, game design documents are pretty useful for keeping track of everything. Oh, okay, let's see here. So this is the example game design document outline. Title page, game name, game overview. This is a pretty well fleshed game design document. This is another example, but you'll start to see some similarities once we see more and more game design documents. So in this case, this has title page, game overview, gameplay mechanics, story setting, levels, interface. Basically what you do is, well, this one even goes ahead and says, oh, what's the purpose of a game design document? Well, that's handy. But yeah, what this says is true. Game design documents for big or medium-sized projects prevent wasted time and effort, and they also let you develop a workable schedule. And also, it prevents feature creep. Speaking of feature creep, there's actually an important point to be made. In software, there's fixed or flexible schedules, and there's fixed or flexible features. If both of them are fixed, then you'll have much pain. If both of them are flexible, then you'll probably feature creep into infinity. So therefore, it's good to have either the time schedule fixed or the features of a game fixed. That's something important to note for any software development. More examples of game design documents. Game design document is a blueprint from which a computer or video game is to be built. That is so true. Okay, these are examples. Let's see an example of a storyboard. In this case, I'm going to search up a very good video I saw a long time ago regarding, let's see, what was it? I'll search up Unity Learn, which is, by the way, a great site for learning Unity stuff. Let's search up, let's see, advanced game design, I think. Post-processing, okay, cinematic design and Unity. So this is an example of a course which is 2 hours long, but I want to show you one specific by the way, definitely check out this in Unity Learn if you want to see this in more detail. The storyboard example, where is it? Here it is.
As previously mentioned, there are a couple ways that we can create the shots for our storyboard. We could quickly thumbnail them out, we can nicely render them, or we could just take screenshots. So that's what I'm going to do here. Feel free to draw them out if you prefer. So let's go into Unity, and there's a few little setup things that we want to do before we get going. I'm in level 1 right now, and I want to keep an eye on the game view while I'm moving around the camera trying to figure out what my shot should be. So I'm going to grab the game tab, and I'm going to drag it down and dock it next to the project tab. I've also made sure that my aspect ratio was set to 16:9 rather than free aspect. If it's set to free aspect, you see that no matter what size our game, you can see if I tried the angle of our camera. Indicators here. And I'm going to pull this down a little bit so general size. To move this screenshot, if we go to image size, the native snipping tool. And I'm going to copy that by hitting Control C and go back into Photoshop. And I'm going to hit Control V to paste it in. Now you can see that the size of our screenshot is significantly smaller than the size of our storyboard template. And the reason for this is if we go to image size, we can see that the resolution's at 300. So what I'm going to do is bring the resolution down to 72, hit OK, scale this back up to where I can see it, and then just hit delete to get rid of that pasted image, and then hit Control V to paste it in again. And that's a much more logical scale. Just remember to save a copy of your template, that way you don't overwrite the original resolution of it. So now I'm going to move this screenshot into our first panel, and I'm going to scale it down so it's appropriate. I'm going to do that by hitting Control T, and then holding Shift to scale this down at the same general size. And it doesn't have to be perfectly set up for the box that these shots are in. This is actually closer to a 4:3 rather than a 16:9. So that's not a big deal. What's important is that each shot has its own dedicated area. Enter to lock that in, and I'm going to pull this down a little bit so it is centered. Use the arrow keys to offset it. There we go. That's good enough. This is going to be the start of our first shot. Now, as it is right now, this isn't really revealing what we want our shot to be. And that's why it's important to first write notes, but also to add in some extra indicators here. Let's do that next. First, I'm going to go to my text tool, and I'm going to indicate that this is shot number 1. And our text is now gigantic because we're no longer at 300 dpi, so I'm going to pull this down to something reasonable. Looks like 14 will be fine. And now I want to show that our character is going to be running into the scene. So I want to represent that by an arrow. So you could either hand draw an arrow with the paintbrush tool, or you could use one of Photoshop's native shapes, which can be found under the line tool if you left click and hold, and then choose custom shape tool. Notice that my shape is already set to arrow, but you could find the arrows by clicking on this drop down here. If you don't happen to see any arrows in your list of available shapes, click on this little gear and then select arrows. When it prompts you, just go ahead and click append. And then you'll have a collection of arrows to work with. And actually, this is a nicer selection than what I had up here, so I'm glad I added this. So I'm going to select an arrow shape that's going to represent our character running into the scene. And this little wiggly arrow looks perfect. So I'm going to select this. And note that I have my arrow set to draw pixels rather than a shape or a path. Finally, notice that right now I can't actually draw on my board. If I click, it says that this type of layer must be rasterized. What this is saying is that my active layer is actually my text for my shot number. So I'm going to click OK. And I'm just going to create a new layer. There we go. And let me select a color other than black. For character movement, let's go ahead and set this to yellow. I want to use red for showing camera movements. So other animations need to be represented in a different color. So I'm going to click OK. And I'm going to draw an arrow in. And notice that with this shape, you can't really draw at an angle, but that's fine. Because we've dedicated our arrow to its own layer, we can now hit Control T and rotate that arrow to where we want it to be. There we go. So we've shown that our character is going to run into the scene and stop. Then we're going to have a pause and then have the camera begin to pan a little bit up this bridge. So I'm going to add in a secondary arrow that shows a camera panning movement. And I'm going to use a different arrow shape to represent the fact that it's a camera and not the character movement. So before I do anything else, I'm going to create a fresh layer so I don't accidentally mess up the angle of this arrow. I'm also going to come over to my layers and name this so I know what it is. Create a new layer. And let's go ahead and name this since we're here. I'm going to change the arrow shape to something much bolder and straight because we're going to have smooth movements with our camera. I'm going to set this to red. We'll draw out our arrow and then rotate it to show it following along the path of this bridge here. So this actually shows everything that we want to have happen in this shot, but for somebody who didn't see us actually put this together and talk through it with us, this is kind of confusing. And that's why we're going to add in this little description. We could also potentially add numbers to our arrows so we know when the actions are occurring and in what order. But first, let's write that description. I'm going to go back to my text and set the text color back to black. And I'm going to type out the description that we just discussed. There we go. So player runs in the level and stops as if shocked. After a pause, the camera pans along the bridge. I adjusted the height of my text so it fit on the lines. If you need to do that, all you need to do is go to Window and select Character, and then adjust this value right here with the text highlighted. So to show that really quickly, we can adjust that like so. So to add that extra level of clarity, let's go ahead and add numbers to our arrows. I'm setting the color of my numbers to white so it's easier to see on our background. And let's add those numbers to our description. Great, our first shot is done. Now let's go and check our list. We have the option to have up to 2 shots for our player entering the scene, but I don't see a need for it. I think it can all be done in one shot. So now let's move on to establishing those narrow pathways.
Okay, that was an example of storyboarding. In this case, it's a pretty low level one, focusing on Photoshop as much as storyboarding. But this is more production leaning storyboarding process. You can extrapolate it for the design concept stage too. Instead of having a final shot, what you just have is some placeholder characters, probably a little more detailed than a stick figure. An important note is they separated the colors between entity movement, yellow, and camera movement, red, as well as the squiggliness of the arrow. Once all 6 of these shots are taken, it makes it really obvious to the reader of the game design document, as well as the storyboard, how the story will happen. So that's an example of a low-level example of storyboarding. Okay, let's get back to the slides. So, that's it for the tutorial. If you have any questions of any design questions, you can ask us in social media or on email. I highly suggest you look over the concepts mentioned earlier, for example, the 10 tools of design, and look at your favorite game and try to think about how the game utilized these design elements. That will immensely help you recognize, first of all, what type of game you like playing, and secondly, how to design more games that are similar to or extend upon games you like already. Not to mention designing games that appeal to a broader audience of people. As always, this is how you can contact us, and that is it for this tutorial. Nice meeting you all for the last tutorial of this semester. Alright.